Alrighty, Tuesday. So we've got midterm review here, if I remember right. Let's double check. And then next week is break, right? So midterm review today. Midterm will open on 2/23 at 2 p.m. And then it's just like the quizzes. Open it, close it, anytime, come back to it whenever you want. There's no time limit, and you have to submit by, aside from the due date of 3/7, 2 p.m. So as long as you get it in, if you want to get it done, great. Again, it's designed that you can sit and take it in an hour 15. If I want to watch people take a test, I don't, because it's terribly dull. So if you want to get it done and out of the way and have a break, awesome. If you want to worry about it next week over break, great. If you want to worry about it the week after, go for it. I mean, totally up to you. Do let me know if the questions don't make sense, though. Like, reach out to me rather than just turn something in. And I've seen people that are like, I didn't know what you really wanted, but here. So it's not time, so don't do that. Is that okay? And then, so I don't have plans for a lab on 3/7 because there's nothing this week that's new for us to practice. So I'll post that in Canvas as well. Nothing's planned for lab. And someone did point out the lab from today, I had the due date wrong, so that did change. I think Canvas probably emails you everything and you probably turn them off, but that'll be due on 3/7 as well. So nothing due over break, hopefully there. And then the project that we're working on, I think we pushed that one. So that shouldn't be February 23rd either, because that's Thursday? No, that's the quiz. Oh my goodness. Yeah, March 7th. Okay, so we're good on the project as well. So this will be after break. Good there. Yeah, the quiz I should change. Well, that's this Thursday, because that was our linked list quiz. I wasn't going to do one on trees, because I was going to include all the quiz questions on the midterm, and we won't have had a chance to do that one yet, because we just finished up trees. So this will come from these 4 quizzes, will be the quiz portion of the midterm. And then the long answer questions we'll take a look at. Hopefully I had a chance to look at some of those. Didn't I post it? Did I not post the last midterm? I thought I did. Did I not give you last year's midterm? I didn't do that? Wow, I'm so confused here. Okay, I'm sorry. Let me go grab that one then for you. I'm sorry. So we want 2001. This is winter of 22. Take a look at the quizzes here. Here's midterm. All right. So 1 point for just agreeing one more time to the academic integrity policy. Free point. There's some research that says if you ask students first to agree to the policy, they're more likely to abide by it. So great. We'll ask you. It's open book, open internet, open notes, not open neighbor. Don't ask anyone else. That also means you can't post it on Chegg and then say, hey, look, I found this answer online. I don't know why I have to specify that, but someone did that to me in the past. And they're like, no, you said I could use whatever was online. But you can't go post it online. Okay, so long story. Great, open book, open notes work. And then all work is assumed to be original unless you cite a source. Okay, this is, okay. and then 14 other quiz style questions. Like I literally pulled them right out of the quiz test bank. So you should be able to go back and see all your quizzes. I think I've got most of them scored now. I think I owe you one more. Let me double check. What did I have? I think I got the quizzes. I was looking at those today. Oh no, array-based quizzes. Oh, okay, 2 more quizzes. I thought I got some of those. Hi to my friend. Thanks for donating those bits to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. So I'll get those quizzes graded for you before Thursday. That way you've got all the quizzes in, and you should be able to see the questions and answers if you have any questions about them. For the recursion quiz, several people said factorial was a good example of recursion. It is not. It's a bad example of recursion because it's not efficient. Right? If it's just a loop, just use a loop. Right? Using recursion means you have to store more variables every step of the way here. So something like the Towers of Hanoi that is difficult to write iteratively is a good example of recursion. Fibonacci is not a good example. Fibonacci is just a loop too, right? If it's just a loop, use iteration. But the things that are hard to do, like our backtracking, the maze solver, a lot of people said that that's a good solution because it's hard to do backtracking without recursion. You can, right? We can write it with our own little stack and start adding stuff to a stack, and tracking all that just gets hard on us. So that one was out there. So I should have given you feedback on those ones. Yeah, okay, the other ones are labs we got to do. So, all right, and then long answer questions here. So I just have 3 long answer style questions. I said, hey, given this sort of UML notation, write the class. So here's a class for burger. It's actual weight in grams. With UML, right, you say this is the type of value we expect. Python doesn't force that, but just so you know what kind of value this would be here, an int and a float, and a list of toppings, base cost, and a weight in grams for int. And it says add a method add toppings that accepts a string value, adds it to the toppings list. Add a method get total cost, which returns the base price plus the cost in cents per gram for every gram over the base weight in grams value. So base weight in grams and actual weight in grams. So you could say, hey, I want a burger. The base weight is, I don't know, quarter pound. So a quarter pound is probably like 250. No, wow, 2 pounds is a kilogram. So 500, like 125 grams is probably close to a quarter pound of burger. But maybe you actually order it as a bigger, right? So your actual weight in grams might be larger than that base weight, right? And then you have a cost in cents per gram for every gram over that base amount. So that's that get total cost, right? Over the base weight. Add a method for actual weight in grams, a set method for actual weight in grams. It can weigh less than the base weight, not less than 0, and no more than a kilogram. Right? At that point, it's not a burger anymore. It's just a monstrosity. Right? I think probably even at like 500 grams are probably at the monstrosity level for a burger. But again, I'm just making numbers up here. And then the cost per cent in gram should be arguments provided in the init method and not have a set method. This sort of idea, we're saying don't include sets for these. You give them when you init, when you create the instance of the object, and then you don't change them. Right? If we don't have a public set method, you don't change them. And then write unit tests for get total cost to ensure 100% code coverage. This was all one long answer style question here. So write it the class, write the functions, and write your unit tests. That was one. Please do this in PyCharm. Don't type Python code here. Right? I had someone do that once. And they're like, I'm sorry, it's probably formatted really bad because I typed in Canvas. So it's open. Please use PyCharm and just copy paste things. Right, that should be fine. You paste the class and paste the unit test in. I can figure it all out from there. It shouldn't be too bad. Right. So you'll have a question similar to this. Write a class, write unit tests. So it just won't be the burger class. Right? And I can go over a solution to this in a little bit if you want to talk about it, if we talk about the questions. And then here's a question about a list of lists, dealing with 2-dimensional lists. So this is just some nonsense because I have to make it different every time. But you'll have a question about 2-dimensional lists. So the sum of prime values or values in prime indexes given some 2D list that returns the sum of all prime number values and all values whose index is prime. So if this is my 2-dimensional list, any of the prime values in here get added up, or if their index is a prime number, right? So this is, we'll just say from 0 on up, right? It's not 0, 0. We'll just say this is 0, this is index 1, index 2, index 3, on and on and on. So any of the indexes that are prime, we would also include those values in the sum. So as we're looping through the list, we have to do a couple things to figure out whether or not we're including the value in the sum or not. Be sure not to add your value twice. And I gave them, hey, use this for prime number checking, or just go Google it. It's not hard. Inventing whether or not a number is prime is not the tricky part of this exercise, right? So go use one. Go find one, cite your source, or here was one before. Prime numbers are pretty common. And then the last one, write a recursive function. So specifically recursive. You remember those private helper functions with more arguments are useful. So that way you can pass in a start and an end value, those sorts of things, and not make the public function include them. And you're going to do jumble recursive. Returns a new string, but the characters have been rearranged so the last character is moved to after the first character. The second to last character is moved to after the second character, and so on and so on and so on. So we're jumbling up the string here. So the last character gets put after the first one. So AG, and then the second character is the second to last character, BF. And then the third character gets the third to last character after it, CE and D. So this is a recursive function to do that. And then write it as an iterative function. Do it both ways. Right? Whichever one you want to start with, go for it. Right? If it's just a loop, just do it as a loop, and then the recursive call is essentially the loop happening there. Right? When we looked at those recursive functions, I know this is a while back now. We haven't done recursion in a little bit, but that's the idea with this. So show me that you can write it both ways. And that's it. So 3 long answer questions. You'll have one on recursion, one on two-dimensional lists, one on classes. So again, ideally you can get it done in an hour 15. So I figure each of these takes about 20 minutes or so. That's how I try and imagine this in my head. If each of those takes 20 minutes, that gives you another 15 minutes for the quiz style questions, which they're out of your existing quizzes. Shouldn't take you more than a minute each, right? Okay, cool. You want to do these questions up front? You want to look at them for a little bit first and try, or I don't know what's more useful for you. Okay, I'll just do it. Yep, you got it. Player up PyCharm. All right, we'll start up a new project. And I did post the lab code, so we did the linked-based lab, which is pretty much exactly in the book, but I flattened it so it's just one class without all the subclass stuff or superclass stuff, because it's awesome and great and a good thing to do, but confusing when you're trying to follow and understand what's happening. At least it confuses me, so I figure it confuses you folks too. All right, so midterm review. Oh, I hit the wrong button. Shoot. Midterm review. This one. That's the right button. All right, so we're going to write this burger class. Burger. All right, so this class for burger. We'll define an init method, and then init is supposed to take values for cost in cents per gram, base cost, and base weight in grams. Right? We need cost per gram, base weight in grams. What was the last one here? Base cost. Base cost, not that one, this one. Base cost. Okay. Oops, that tab did funny. Hitting the tab key. That's all right. Let me just get rid of all these. Why is my tab key not working? That's weird. All right. My tab key broke and I'm really sad. I'm going to restart PyCharm because that shouldn't happen. Tab should work. Let me try this one more time. Okay, now it's working. That's super weird. So self.cost per gram is my cost per gram. Self.base weight in grams, the base weight in grams. Self.base cost, base cost. Right, and then we need other things. Right, we have the topping list, self.toppings equals an empty list. And then what else do we have? We had actual weight in grams, right? So an actual weight in grams, self.actual weight in grams. 0 until we know otherwise is probably fine here, right? We don't know how much it actually is for this burger that's getting ordered. cost in cents per gram, cost in cents per gram, in cents, right? We have two different units of measure here. We have the cost measure and then we have the weight measure. Just try and be specific, because if you just say cost per, I guess people might have assumed it was dollars, not cents. I don't know. I was probably going to do that actually. The base cost and base weight in grams, base weight in grams, base cost, toppings, actual weight in grams. Okay, so we got our attributes. Now we need a bunch of get methods, right? If we're marking these as private, which is our good practice when we're doing object-oriented programming, we'll need our public. If you didn't include them, you're not going to get marked down, but we should be doing these sorts of things, right? As long as you have the things that are required, you're okay. But we always want to be trying to follow those good practices, and sometimes they take shortcuts and feel bad about it. So okay, get cost in cents per gram turns by self.cost per cents in gram. Find a get base weight in grams. Self dot base weight in grams. Get base cost. Self dot base cost. This should probably also be what, in cents? We don't know otherwise. Because if we're saying cost, we should tell them what it is. That's a good thing here. We're going to try and follow that in cents. Define get toppings. Now, when you're dealing with a list, remember, if you give someone back the list, they have access to modify it. So generally, when we deal with lists, we want to give someone a copy of our list. We're going to return our sliced list here, self.toppings sliced, which will give them a copy of all of those strings. Right? This ensures I can't modify the list. Original list. You get a copy. Original. There we go. And again, you're not going to get marked down if you don't do that, but these are the good habits we should be getting into now that we've done a lot with object-oriented programming. We get toppings, and then a define get actual weight in grams. Turn self dot actual weight. Now for these like integer values and float values, we just give them back, right? So this is probably a little bit of review, but it's always good to talk about. So even if they change it, we didn't give them a reference to this value. We gave them this is what the value is, and they're just it's not gonna change anything. All right, and then add toppings. Accepts a string, adds it to the toppings list. So we're going to define add topping, given a topping. Self.toppings, append the topping. Awesome. I hope you don't want to take it off, because once you add it to your burger, we have no remove method here. It's okay. And then we have a probably set actual weight in grams, probably do next, because otherwise get total cost to be boring. So we'll have a set actual weight in grams given a weight in grams, or actual weight in grams, weight in grams. And we need to make sure this value is sane, right? Not less than 0, not more than 1,000. So if my 0 is less than the actual weight in grams is less than or equal to 1,000, right? I guess 1,000 was okay. So if it's within range, we're good. We'll take it. Self dot actual weight in grams is the actual weight in grams. Otherwise, we're going to raise a value error. Invalid weight must be between 0 and 1,000. Sure. Again, didn't specify using an exception, but that's the good thing to do here, right? If we just silently set it to 0 and don't tell them, hey, you told me you wanted a 2-kilogram burger, you're going to kill yourself. Like that's a heart attack on a plate. They don't know that it didn't work, and things won't function properly later. So we'll do that. And then we want a get total cost here. So we needed to, if the actual weight is more than the base weight in grams, we're going to charge them for it here. So if my self dot actual weight in grams is greater than the self dot base weight in grams, we need to add something here. So probably need like a cost, right? So cost is my total cost, self dot base cost in cents. And then if we went over that base weight, then we'll take that value. So cost, we're going to add to it my self dot actual weight in grams minus the self.base weight in grams for some order of operations here, right? Times my cost in cents per gram, right? And add that to cost. And return cost. Right? Take the base cost. Sure, it's a $5 sandwich no matter what. And then for every gram over, you pay another penny or something. I don't know. Whatever you want to come up with here for your burger shop. Right? For every gram over the base weight. Cool. So now we have a class. We'll return the cost. So for unit testing, if we're just looking at this here, in terms of code coverage, all we need to make sure that this if block runs. Right? There's no other else that we need to check for. We could, it might be a good idea to make sure that if your actual weight is less than the base weight, you get just the base cost. But in terms of code coverage, just one test will do it here. Right? And that'll be okay. So let's right click and say, go to test. Yeah, let's go make a test. We want to test get total cost. It's really the only one I asked for, right? So let's get total cost. Cool. So we need to say from main import burger. We're going to arrange. We're going to act. We're going to assert. So we need a burger here, right? So we'll make our burger equals burger, and it needs what piece of information? The cost in cents per gram. We'll just say 1 cent per gram over. The base weight in grams, we'll say maybe 100 gram burger, and the base cost is maybe 100 cents. Sure, I mean, the numbers don't matter too much here. Should be okay. So then we're going to have an expected cost. So we know we want to go over the base weight. So why don't we make it, if we'll say it's a 200 gram burger, that's 100 grams over at a penny per gram, should be another 100 cents, and it already costs 100 cents, so it should be 200. Expected cost in cents should be 200, right? And then we'll make the burger. Oh, I'm sorry, we have the burger. Now we need to set the weight, right? So set actual weight will be 200. Right? This is all things we're arranging. We're not testing the set weight function. We're testing the get cost, right? So the actual cost in cents is going to be my burger dot get total cost. That should probably also say in cents. Now I feel bad. Get total cost. I'm going to refactor rename that. Cost in cents. So it gets renamed everywhere. Yeah. Okay. Get cost in cents, and then we'll assert. Too many tabs here. Self.assert equal my expected and my actual. Let's give it a try. Let's run our test. And it passes. Very cool. So we got 200 grams. And we know in terms of code coverage, this one ran because the actual weight was more than the base weight. So you'd copy the unit test method here. You can copy the whole thing. You can copy just the method here. I don't really care. And then your class. We'll just copy paste both those in. We got burger. Questions? So just the one here. Usually we would do the other ones, but again, this is meant to be short, and this is the one that's really interesting. The other stuff it's good, but you've already done that. I don't need to see you do it again for the midterm. Yep. All right, our function sum of prime values or values in prime indexes given some two-dimensional list. Oh goodness, this one's a lot of fun here. All right, so I'm just going to throw it in here in main. Is that okay? And we'll define this as a function. All right, so we need to loop through every value in every row, and we need to be counting the indexes. So I need first the sum, right, starts at 0, or I don't know, sum of values will be 0, right? And then I need a index counter. So this is my current index is 0. And then I can say for row in sum 2D list, for value in row, right? So my index I'm going to count separately. I don't need the index values because the index values are going to be, each row will restart at 0. And that's not useful to me because I need to just keep on counting. This was 0, this was 1, this was 2, this was 3, this was 4. And we need that is prime here. So Python is prime check. Look at that. Sure. This is not actually a great function here. We don't want it to print. We don't want that either. We don't want that one. Use prime function. There we go. Wow. That's a neat shortcut here. If n is 2 or 3, return true. If n is less than 2 or n mod 2 is 0, return false. If n is less than 9, return true. Because if these ones aren't already false, we're just shortcutting there. Then if n mod 3, return false. Otherwise, do this thing. Wow. Look at that. How fancy is this one? Because all primes greater than 3 are in the form of 6n plus or minus 1. Start with f of 5 and test f plus 2, and then loop by 6. This one hurts my head, but sure. I'm going to skip that one because that one hurts my head. This is the easy one here. Most people do something like this. Definitely not as efficient, but that's okay here. We'll just add this one in. And we will cite our source, right? Because this is what we do in academia. Actually, not a bad habit for real life either, because that way you know where you got your answer from later. You got to go back to it. Is prime is named funny here. Is prime. So you're never going to have a factor greater than your square root. That's what we do the shortcut to the power of 0.5 is our square root. Okay, that's the shortcut. Most people don't come up with that on their own unless you're like actively doing this in math class and that's in your head. So sure. Anyway, so if my value, or if is prime of the value, right, or is prime of current index. We're going to take our sum of values, that sum of values plus the value. Right? Whether or not this works or not, we're going to take our current index plus 1. So it starts at 0. We keep on increasing it. We just loop through every row, loop through every value in every row, add 1 to the index after we've checked to see if that index is prime, because we want to start at 0. Right? Okay, so far? So I think this one actually is bad here because it's going to assume 0 and 1 are probably prime, right? I think this is a problem because 0 is not prime and 1's not prime, right? All you math folks, you know more math than I do. So this is not even all that good here. So we can say, hey, if n is less than or equal to 1, return false to make sure that 0 and 1 or even anything negative will show up false here, right? Because we're only returning false if our modulus gives me back a 0 here. And then this ranging too, that's fine. Typically you'd start at 3 and just add your prime numbers, or I'm sorry, add by 2. You don't even have to do the add by 6. So this one's irritating me. You can say if n is equal to 2, return true. I'm adding in some shortcuts here because this is sad. So when we want to step by 2, at least as a quick little shortcut. We don't want to check all the other even numbers, right? And then we can say if n mod 2 is 0, return false. So check for the even, and then we don't need to check any of the evens here. We can just check the odd numbers. That make sense? Okay. Again, just extra optimizations because that irritated me. That was all. So our sum of prime numbers, right? Either the value is prime or the index is prime. We're good to go. Okay. Then our recursive function for scramble. Oh, I'm sorry, we good to move on to recursive scramble? Cool. We'll define a recursive scramble given some word or some string, I guess, right? Now again, you probably want some sort of helper method here because we don't know where we're starting, where we're ending here. So we'll have a helper recursive scramble that takes some string. And then what are we doing? Well, we're scrambling it up here. So we probably need the new string that we're adding to, and we probably need to know what the start and end values are, right? So we'll have our new string and then our start index, our end index, right? So what we want to do is we want to take the new string and we want to append to it here my sum string at the start index. and I'll take my new string, and I'll append to it my sum string at the end index. And I'll take start index plus 1, and I'll take end index minus 1. And I probably only want to do this as long as they're bigger than each other, right? If my start index is less than the end index, right? If they're the same, I don't want to do anything. So that's if I have an odd number here, like if I have 0 and 4, 1 and 3, 2 and 2, I just want that letter one time. So if they're less than, great, here, we'll do this. Otherwise, we can take my end index, my new string, and then I will add to it my sum string. We can just take either the start or the end. I guess that's else if my start index is equal to the end index, right? Because if it's not, right, the last case, once they've passed each other, then I can return my new string. Yeah, I think we do that. Yeah, we'll return the new string. And we also, once we've done this one, we can return the new string as well. We'll just give it back. We're done. If we're not done, right, then we need to return my recursive scramble, given sum string, given the new string, given start index, and given an end index. Right, here's the recursive call. It might have been easier to do the loop first. I don't know if this is making a lot of sense here. Right? So if we haven't crossed or met here, take the letter from here, take the letter from here, and then do it again. If we meet, we just have one letter in the middle because we have an odd number of letters. Take that letter, give it back. If we crossed each other, right? If we had like 4 letters, we had 0 and 3, and then 1 and 2. The last call would be start is 2, end is 1, and we've crossed our paths. We're done. We don't need to do any more scrambling here. So we can just return my recursive scramble, given the sum string, empty for a new string here. The start index is 0, and the end index should be the length of sum string minus 1. And where's the last index? Right, so we should try it. So we want to print my recursive scramble of, what do we have here? A, B, C, D, E, F, G. Let's run that one. So A, G, B, F, C, E, D. That looks like it was scrambled, right? And then probably worth trying like a different number here, right? We want an even and odd, just to make sure that both of these cases are working properly for us. So AF, right? And then BE, CD, right? Looks correct. Cool. That's our recursive scramble. So again, this is really just a loop here. So to make this iterative, an iterative scramble. Is this too small? I realized I didn't zoom in here. I'm sorry. I wasn't zoomed very far. Scramble, given some string. We're going to make a new string. Starts off as blank. We'll have a start index is 0. We'll have an end index is the length of some string minus 1. And while the start index is less than the end index, we'll take new string. We'll append in here start and end. We'll add to it here. When the loop is done, right, we can say, hey, if start index is equal to the end index, I'm going to take my new string, add one last letter here. When we're done, we can return the new string. Right, this is the loop version. We don't need the recursive calls because it's just a loop here. And this is actually more efficient because we don't need to track this string at every step of the way here. Imagine if you had like an entire book as a string. We're going to store that string, whatever number of characters divided by 2 is. Right? Because we are going to call recursively every time, building a new string every time using the sum string. This is going to be awful here, building out this new string. This is terrible with recursion, but it works, right? You can, just doesn't mean you should. And we'll try our iterative scramble. There we go. And we'll do it for both of these as well. So we'll print the iterative scramble. Make sure it comes out the same. So AG, BF, CED, AG, BF, CED, AF, BE, CD, AF, BE, CD. They look like we get the same answer for both. Okay. Questions, thoughts, concerns? You okay with these? Again, so you'll get a question on classes and a unit test. You'll get a question on 2D lists, probably prime numbers because they're fun. I don't know, I like prime numbers. And then a question on recursion and iteration. Okay, that's the goal for the midterm. So let me commit this to GitHub here so you have it. Let's see, we want 2001, midterm review. All right. Oops, I made some changes. I gotta go pull. I had the lab. Awesome. Any other questions? Cool. So I will see you later in March then, right? When are we coming back? March 7th, right? Yes. 2001. Yeah. March 7th. I'll see you then. Okay. Reach out if you have questions. If it's phrased funny in the midterm, it's because I wrote it funny. Just ask, right? Happy to answer those questions. Or post in the Discord and then everyone will see your question. That's great too. But yeah, let me know if it doesn't make a lot of sense. And I'll make sure I get those quizzes graded for you before Thursday as well. Okay. Thanks, everybody. Have a good winter break.